Welcome to The Explainer. So today we're zeroing in on two fist-size, kind of bean-shaped organs that are honestly probably the most underappreciated biological marvels in the entire human body. Far too often we just write them off as simple waste removers, like a basic plumbing system for the body. But actually, let's completely reframe that right now. Your kidneys are the ultimate, absolutely hardest working purifiers your body has. They are constantly making these literal life or death micro adjustments just to keep your internal environment perfectly balanced.
Okay, let's dive right into this with a number that kind of blew my mind, 150. In a single day, your kidneys filter about 150 quarts of blood. Think about that for a second. That means your entire blood volume is circulating through these filters many, many times over every single day. And the crazy part? Only about 1 to 2 quarts of all that actually becomes urine. The rest of it is meticulously cleaned, adjusted, and sent right back into your bloodstream. But this massive volume of work brings up a pretty provocative question. If your kidneys work this incredibly hard, why do we completely ignore them until they fail? It's a huge paradox in human health. I mean, we're tracking our heart rates on our watches, we're obsessing over gut health, but our kidneys, they just operate in the shadows. They are so efficient and so incredibly adaptable that they basically hide their own distress until it's almost too late.
All right, Section 1, the ultimate blood purifiers.
To really put this workload into perspective, every single minute, these organs process about a half cup of blood. But they're doing way more than just pulling out the trash. They are actively balancing water, salts, and minerals, specifically stuff like sodium, calcium, phosphorus, and potassium. Without this super precise minute-by-minute balancing act, your nerves just wouldn't fire right, your muscles would completely cramp up, and your tissues would essentially start shutting down. It's absolutely crucial.
Moving on to Section 2, inside the microscopic filter. So if we zoom way, way in, inside each kidney, we'll find about 1 million of these microscopic filtering units called nephrons. Now, right at the start of the nephron sits the glomerulus. You can think of it like a tiny cluster of blood vessels that acts as a physical bouncer at a club. It lets water and small molecules pass on through, but it keeps the big, VIP large proteins and blood cells safely inside the bloodstream. From there, that filtered fluid enters the tubules, and this is where the real magic happens. The tubules basically sort through the fluid, reabsorbing almost all the water and nutrients back into your capillaries while secreting all the excess acids and wastes to form urine. But hey, nobody's perfect, right? What happens if a really valuable, large molecule accidentally slips past our bouncer? Well, the kidneys actually have a backup plan right there in the proximal tubule. It's an active process called pinocytosis. Think of it like a cellular conveyor belt. The cell membrane literally folds inward to swallow up those large molecules, like stray proteins, and pinches off to form a little bubble inside the cell. The protein is then digested down into amino acids and reabsorbed back into the blood. Now, this requires energy, sure, but it ensures absolutely nothing valuable gets lost as waste.
And to power all of this intense, non-stop sorting, the kidneys rely on specialized transport systems. Primary active transport is kind of like paying cash up front. It directly burns ATP energy to forcefully pump substances against the current. But secondary active transport, that's a bit sneakier. It acts more like a cellular hitchhiker. It piggybacks on existing ion currents, so as sodium naturally flows down its gradient into a cell, it actually provides the momentum to drag a glucose molecule uphill right alongside it. It's a brilliant design that ensures practically 100% of your filtered glucose is safely recovered.
Which brings us to Section 3, the Chemical Balancing Act.
Okay, we really need to talk about osmolarity. Basically, this is just the amount of solute, like sodium, per unit volume in your bodily fluids. And your kidneys monitor this relentlessly. Why? Well, because extreme variations in osmolarity will literally cause your cells to either violently shrink or painfully swell up with water, totally destroying their structure. This is exactly why your kidneys have to balance your water and sodium excretion so carefully. It's literally keeping your cells intact.
To manage this incredibly delicate balance, your body calls in two main hormonal heavyweights. On one side, we have antidiuretic hormone, or ADH. Think of ADH as the water saver. When your plasma gets a bit too concentrated, the brain secretes ADH, telling the kidneys, hey, insert some water channels and reabsorb water, which dilutes the blood. On the flip side is aldosterone, the sodium saver. This steroid hormone from the adrenal cortex commands the distal tubule to reabsorb sodium. Working as a team, these two dictate exactly how concentrated or dilute your urine is going to be.
And this right here is honestly one of the coolest parts. Your kidneys act as their own emergency command center. Say you lose blood or get super dehydrated, they directly sense that pressure drop and immediately deploy a hormone called renin. That kicks off this rapid, step-by-step cascade that results in the production of angiotensin II. This powerful hormone then triggers the secretion of aldosterone. The end result? Your kidneys simultaneously clamp down on both water and sodium, aggressively conserving your body's vital fluid volume right when you need it most.
Let's pivot a bit for Section 4, the silent epidemic, chronic kidney disease.
Chronic kidney disease, or CKD, is notorious because it is a truly silent disease. It often goes entirely unnoticed because it quite literally cannot be felt. Now, why is that? It goes right back to how brilliantly adaptable the kidneys are. When some of your nephrons get damaged, the remaining healthy ones undergo what's called adaptive hyperfiltration. They literally work harder to pick up the slack. It's an amazing adaptation that initially keeps your blood work looking totally normal, but the dark side is that it forces those healthy nephrons to burn out over time, totally masking the early damage. And because of this crazy masking effect, the statistics we're looking at are just staggering. As many as 90%. 90% of people who have chronic kidney disease remain completely unidentified. Millions of people are walking around right now, losing nephrons every single day, and they have absolutely no idea because, well, they feel perfectly fine. So how in the world do doctors actually uncover and measure this hidden decline? They use a specific metric called the glomerular filtration rate, or GFR. It's a calculation that reveals the exact rate at which your glomuli are filtering your blood. Because CKD represents a progressive and sadly irreversible decline in function, tracking the GFR is how medical professionals map the relentless progression of the disease. Doctors actually map this decline across 5 distinct stages based on that GFR number. It usually starts incredibly subtly in stage 1. You have a normal filtration rate, but maybe some underlying signs of damage, like a little protein in the urine. But as those overworked healthy nephrons inevitably burn out, the GFR starts dropping. You slip from a mild decline in stage 2 all the way down to a severe decline in stage 4. By the time someone hits stage 5, the filtration rate has plummeted below 15. That is end-stage renal failure, meaning the patient literally requires dialysis or a kidney transplant just to survive. I know that progressive nature of CKD sounds pretty daunting, but here's the good news. Secondary prevention is highly effective, and that is incredibly empowering. It's all about modifying the risk factors that we actually have control over. High blood pressure and diabetes are by far the leading drivers of kidney decline. Managing those, along with quitting smoking, getting more physically active, and maintaining a healthy weight, these are vital steps. Detecting the issue early and actively managing these very specific factors can drastically slow down the disease's progression. Your kidneys are absolute biological masterpieces. They adapt, they compensate, and they work grueling overtime to hide their own damage from you, all just to keep your body perfectly balanced. But as we've seen, their silence is a serious double-edged sword. So I'll leave you with this to think about. Are you listening closely enough to your own body to protect your kidneys before those silent filters finally fail? Take care of them, and they'll take care of you. Thanks for joining this explainer, and keep learning.